Twice a week for 5 weeks in a row, a researcher carries a marmoset away from its mate. The fluffy, squirrel-sized monkey doesn't know why it's being separated from its partner and taken to a strange place. It doesn't know when or even if it's coming back. And marmosets form strong bonds, so this is stressful. Why are their handlers doing this to them? Well, they're trying to answer a question that turns out to be a lot harder to study than you'd expect. What does loneliness do physically? How does it impact our biochemistry and our brains? What's going on in our blood and our cells when we're lonely? And the answers matter because loneliness among humans has become a crisis. According to the American Psychological Association's most recent stress survey, more than 6 in 10 U.S. adults reported feeling lonely. Half said they felt isolated, left out, or lacking companionship, often or some of the time. And according to a former Surgeon General, this is as hazardous to our health as smoking. But how? Why? A scientist in San Antonio is studying these tiny monkeys to see how loneliness impacts them, and a psychiatrist in California is an expert on how loneliness impacts us. We're going to talk to them both to hopefully better understand what loneliness is doing to our bodies and brains, and then we'll try to figure out what might help. Over 2 episodes of Petrie Dish, we're exploring the loneliness crisis, starting with the lonely body. From Texas Public Radio, this is Petrie Dish. I'm Buddy Petrie.
Support for TPR comes from the University of Texas at San Antonio's Brain Health Consortium, a pioneering research hub advancing neuroscience, neuroengineering, precision medicine, and more. Learn more at utsa.edu/BHC.
Aaron Musto is a scientist at the Southwest National Primate Research Center, part of Texas Biomedical Research Institute in San Antonio, Texas. He's a behavioral endocrinologist, which means he studies how hormones shape behavior. His subject, the common marmoset.
They look like a squirrel and sound like a bird, and they kind of fluffy tails and fluffy tufts coming off the side of their head. And they make a lot of vocalizations. And again, they kind of sound squeaky like a bird almost. And they're kind of mischievous and troublemakers.
They are tiny, tree-dwelling monkeys from Brazil, and their social lives look a lot like ours. A bonded male and female raising their offspring together, sometimes with grown kids sticking around to help.
They form strong social attachments with their partners, and they maintain that attachment. They will defend their family as a team. So if a predator or a threat approaches in the wild or in captivity, they'll kind of all jump together and try to coordinate defending their territory or their family. So they're very kind of strong social unit.
This human-like pair bond in particular is rare in the animal kingdom, which is why Musto's team uses marmosets to study something as human as loneliness.
Because they're so dependent on their social relationships and the composition of the social group, anytime there's a disruption in that, it's kind of a natural stressor for the animal. So you can imagine if you have a social partner that you spend the majority of your adult life with, and you're separated from that partner, that's going to be a source of significant stress.
Musto's team took 14 marmosets, each already living in a long-term pair bond. They separated them 10 times, twice a week, for 5 weeks, for 4 hours each time. During their isolation, researchers collected urine samples to track a hormone called cortisol.
And cortisol is kind of considered that fight or flight mechanism hormone, and people will call it the stress hormone. But really what it's doing is it's a hormone that's involved in in the metabolic process that is needed when you're in a stressor, right? So we call fight or flight. In both those cases, whether you're fighting or running, you need kind of access to metabolic resources so that you can be ready to spend energy to get away from the stressor. But in this case, it's not a stressor you can really get away from, right? So we separate them for a period of time that's known to induce the stress response. And what we're interested in is what's happening during that period of isolation when they're separated from their partner, but also when we return them to the home cage, what happens during that reunion? We're kind of interested in both the physiological aspect of that and the behavioral aspect of that.
In a healthy response, cortisol spikes when something unexpected happens and then settles back down once the potential threat recedes. And in half of the 14 marmosets, that's precisely what happened. Their cortisol spiked when they were separated, then it settled after they were reunited.
And then we have marmosets who just don't respond. They're essentially not reacting physiologically or behaviorally, which was very surprising to us. And essentially we call these non-reactors. Their physiological response is not what we would consider normal. So it's attenuated, it's reduced.
You might expect that a flat hormonal response would indicate calm and would be healthier than a sudden surge flooding the body with fight or flight hormones. But that is not what Musto's tests found.
This particular pattern of response, this non-reactor phenotype, is associated with a lot of the bad health parameters that we link to poor health outcomes, bad blood chemistry, markers of inflammation, and things like that we would normally associate with less healthy aging. So having this loneliness may kind of lead to this kind of chronic dysregulation of cortisol that may kind of increase the inflammation response. And inflammation, of course, is kind of the big bad thing when it comes to health and aging.
All right, so in humans, research has found that chronic loneliness can increase the risk of heart disease and stroke by around 30%, and lacking social connection increases the overall risk of premature death by more than 60% compared to those with strong relationships. That's the important part there. Relationships in humans appear to be a buffer. And Musto found that relationships are a buffer in his marmosets, too. And like in humans, this also seems to be connected to cortisol. Those who showed a healthy cortisol surge also tended to be the ones who sought out their partners at reunion, and it was the partner-seeking behavior specifically that predicted how quickly their cortisol came back down to normal.
So what happens after the stressor is over? When animals engage in increased social behavior, a good affiliative social behavior, things like just being near a partner or getting grooming from that partner, that leads to better physiological recovery.
Now, whether they reached out to their partner or their partner reached out to them, if they let their partner soothe them, the reconnection was good for both of them.
So having a strong social relationship, or strong affiliative behavior, you can kind of call it a bond if you want, kind of protects you from these negative health outcomes.
And it isn't about simply having a partner. It's about the strength of that bond. Monkeys who reached out to less responsive partners recovered more slowly, but monkeys that were able to make a connection recovered more quickly. This was true even if the isolated monkey didn't reach out to their partner. So basically, even if a monkey didn't seek help, they could still be helped by others. And that is the most compelling part of this research to me. Marmosets can be helped even if they don't or can't help themselves. This feels very human. I think most of us have been there.
Sometimes when you're stressed, it's hard for you to take initiative to seek out social interaction. But having a partner who comes to you seems to be the critical buffer for this recovery. So the animals that are receiving this comfort are showing this better return to baseline. And that's how we're finding our better recovery.
Social support, community, in stressed marmosets, particularly older ones, improves resilience. Is that true in humans too? And how do our bodies experience loneliness, and what might improve our resilience? We'll explore that with an expert in human loneliness, Dr. Ellen Lee, when Petrie Dish continues.
Support for TPR comes from UT San Antonio, offering degree programs and research focused on workforce development, student success, and health innovation across Texas. utsa.edu. UT San Antonio, the University of Ambition.
Welcome back to Petrie Dish. I'm Buddy Petrie. In May of 2023,
the U.S. Surgeon General today declared a new public health epidemic in America: loneliness. A new report from his office finds loneliness can have profound effects on mental health as well as heart disease, stroke, and dementia.
That's PBS NewsHour anchor Amna Nawaz.
It tracks a decline in social connections and links all of this to billions of dollars in healthcare costs.
The U.S. Surgeon General behind this report was Dr. Vivek Murthy.
Dr. Murthy, welcome back to the NewsHour.
And the conclusions of his 80-page document on loneliness were grim.
Because we've realized that loneliness is more than just a bad feeling. It has real consequences for our mental and physical health. It increases our risk of depression, anxiety, and suicide. But social disconnection also raises the risk of heart disease and dementia and premature death on levels on par with smoking daily, and even greater than the risks that we see associated with obesity.
A feeling, not a virus or a fungus or some kind of chemical in the air or food or water, increases the risk that you'll get sick. It increases the risk that you will die prematurely.
So however you look at it, loneliness and isolation are public health concerns that we have to prioritize.
As Murthy was putting together his report, Dr. Ellen Lee, an associate professor of psychiatry at the University of California, San Diego, was working on one of the first systematic reviews ever conducted on the neurobiology of loneliness, which assessed 41 studies, brain scans, postmortem tissue, the works. She and her colleagues were really trying to get into the nitty-gritty of what's going on in a person's body and brain when they're lonely, to sort of distill the body of research that had found that loneliness had profound implications for human health.
There is a real increase in mortality and morbidity related to loneliness and social isolation, and it's independent of other things. So you may have physical risk factors or genetic risk factors, and then you add on loneliness, which ideally is modifiable, and then you almost double your risk for certain outcomes, including mortality.
To understand why loneliness can do so much damage to us, we have to understand why we feel it in the first place. Like with so many other things we feel that drive us to make changes in our lives, we were probably wired to feel loneliness from the origin of our species to improve our chances of staying alive.
When we think back about the evolutionary view of why we live in societies, being among other people, relying on other individuals is very important for survival. You think about hunters and gatherers, you need other people to help you bring down the woolly mammoth. But when it comes down to it, there is a huge benefit for people who have those social relationships and nurture those partnerships. And we've learned over many years of research that there's multiple levels of support. You know, you have like a romantic partner, a significant other, you have familial relationships, you have relationships with your children, friends, acquaintances, the person that opens the door for you at Starbucks. All those interactions are so important for humans because we rely so much on social interactions.
Kind of like our marmoset friends, our social connections really matter. If you take the evolutionary view, and I do, when your connection to others becomes frayed, that feeling of loneliness serves to nudge you back into the communities that ancient knowledge knows all humans need to survive.
Still unclear to us, based on what we studied, if the changes in the brain cause loneliness or loneliness changes the brain. We're guessing it's bidirectional. So what we studied were these cross-sectional studies that usually assess people who are lonely and people who are not lonely, people who are isolated, people who are not isolated, and they compared brain activities. So we're comparing these two groups, but like I said, we don't really know if it's a chicken or an egg. We don't know if the brain changes propagate loneliness. We do think that's probably likely, but we also think loneliness will change your brain. Isolation will change your brain. What we did find, though, that was so striking was there's a lot of overlapping areas based on these studies. So the studies show that there are specific areas of the brain that seem to be targeted or changed over and over again throughout the study. So in one area in particular is the dorsolateral prefrontal cortex.
The prefrontal cortex is responsible for executive functioning and planning, and it also plays a key role in pro-social behaviors. Now, they're the opposite of antisocial behaviors. Pro-social behaviors are those things we do to help others.
The prefrontal cortex is so important for understanding the perspective of other people and creating and fostering relationships. So being empathetic, understanding what emotions other people are feeling, being able to internalize that and express compassion towards someone else. And so we thought it was no surprise in a way that areas of the brain that are affected by loneliness are also areas of the brain that can help us foster and nurture relationships. It's, providing those social skills, if you will, or social behaviors.
As Dr. Lee was talking, I immediately started thinking about Musto's marmosets, the ones that reached out to their partners when they were reunited and the ones that didn't. It seems like there's a similar thing going on with people. Some struggle to make that move that might reconnect them with a community or even just one other person.
We think it's a little bit of both. Because loneliness is, in theory, a canary in a coal mine, right? So, if we are designed and we need other people around us, if you're feeling lonely, that should be a little bit of a signal like, hey, you need to go find other people, you need to affiliate with other people and sort of regain that social support, that social relationship so that you don't feel lonely anymore.
But again, what if they don't or can't?
People who are lonely may be a little bit what we call more sensitive to social threats. So you may isolate more. You don't want to be rejected. It's more painful when you have an interaction that's not positive. So then you isolate, you have less social interactions, you feel more lonely. And it's a bit of a spiral where you can see people sort of enhancing their own loneliness because of these things.
That reconnection with a partner and the soothing behaviors that helped many of the marmosets return to stress hormone baseline, these people aren't experiencing the human equivalent, and eventually there are measurable changes in the brain and the body. Lee's research finds lonely people mount a weaker immune response even to something as simple as a flu shot. They experience a bigger inflammatory spike after social stress. They have worse sleep, and over the years, more strokes and more heart attacks. That's what happens to a lonely body. But both Musto's work and Lee's seem to confirm something former U.S. Surgeon General Vivek Murthy concluded back on that day in May of 2023 when he declared loneliness a public health crisis.
It's really about the quality of your connections. When I talk to college students on college campuses who are surrounded by hundreds, in some cases thousands of other students, when they tell me that they're feeling lonely, it's because they don't have people who they feel they can truly be themselves with, who they can be open with and vulnerable with. And that was one of the reasons why I issued a Surgeon General's advisory on loneliness and isolation. I wanted people to know how common this was. I wanted them to know how consequential it is for our health. But I also wanted them to know that this is a problem we can address.
All right, but how?
I think that's a really good question. We need to build societies that are sort of designed to foster interactions with each other. So I think part of that is there are a number of initiatives in other countries where they've tried to create like meeting spaces, especially for older individuals, or when you design like a senior living community? How do you foster it so people have places to connect in lots of different ways? Not everybody wants to join the sewing group or the woodworking group. And having things activity-based can be somewhat challenging, but having ways for people to find shared identities or, develop a feeling of belongingness within a group, I think is really important.
That's a lot, but there are people who are working on this diligently. People who are trying to start a movement to create communities that will ease this ache that is creating suffering in our children and our parents and our grandparents and ourselves. We're talking to one of those experts in the second part of our exploration of loneliness, which will be coming out soon. Please subscribe to Petrie Dish wherever you get your podcasts so you don't miss it. And thank you, Dr. Aaron Musto at Texas Biomedical Research Institute and Dr. Ellen Lee at UC San Diego. This episode of Petrie Dish was produced by Jacob Rosati, TPR Vice President of News Dan Katz, and me. I researched, reported, and wrote the show. Jacob composed all of the music, created the sound design, and edited the script. Petrie Dish is a production of Texas Public Radio. I'm Bonnie Petrie. Talk to you soon.